everyone from me too. I'm Till. We'll have a few slides about me in a minute. First of all, I'm really excited to see so many of you here. A couple of years ago when I did these trainings, there were 17 in the room apart from me. Now it's pushing 200, so it seems Qt's going places. It also seems that Matthias's continuous pushing the message out there that Qt Quick is the future and QML is the future is coming through. So welcome to the future, I guess. This is what we do. We do Qt, all of Qt, and nothing but Qt, so we're very, very specialized. That means we know Qt probably better than anyone else. It does not want me to present this, I think. Don't be fooled by the suit. I am, in fact, a programmer. Have been for a while. At KDAB, we believe that trainings should be done by people with a lot of experience doing the stuff hands-on, so we don't have trainers. Same is true for all the other guys in the other rooms doing trainings now. My background is in Linux, so I've been spending many nights making stuff work on Linux, camera drivers and things like that. But then I fell in love with Qt and with the KDE project, so I've been contributing to that for a long time as well. We do Qt consultancy, obviously, so if you need help with anything Qt related, you come to us, hopefully. And we make add-ons for Qt. We have some products, so we have a charting component, a reports component, an updater that is part of KDE tools, and recently we've added a SOAP interface product for Qt. If you want to know more about that, you can come to our booth. As for the trainings, we obviously do them not just here at DevDays, we do them throughout the world, regularly on-site and as open enrollment trainings. We actually have some discount codes, so if you want to pick up one of those, if you want to do one of our trainings later down the line, you can get it a bit cheaper. There's also actually one that we're doing just after DevDays for 3 days. It's about Qt Graphics View, and there's some seats in there. So if you're from the Munich area, maybe, or you can extend your stay, and you want to get that one a bit cheaper, you can get a few seats still in that one. All right, so let's get to the actual subject matter. We have the whole day, which is awesome. Let me do this, and I hope it just stays on the slides now. We have a whole day to cover Qt Quick. There's a lot to cover. It's new, brand spanking new. Who actually has a vague idea already of what Qt Quick is about? Just show of hands, please. OK, so most of you have at least heard of it. That's good. How many of you are programmers, primarily? Awesome. Any graphics people, graphics artists, designers? Whoa. That's a surprise. How many of you have worked with Qt for more than, say, 6 months? Qt, all of Qt, not just QML. All right. I like this. How many of you have worked with Qt for more than 3 years? OK. So it looks like the majority of you actually know Qt, and you're here to learn about QML, right? Yes? Yes? Good. That means I can reference back to concepts that exist in Qt, which actually makes things a lot easier for me. So I was kind of afraid there'd be a bunch of graphics people here that have never heard of programming and want to learn this new fancy thing that they keep hearing about. OK, so what we'll do, there's 4 parts. First part goes to lunch, so about 12 o'clock. We'll do, obviously, an introduction. I'll tell you about all the basic concepts in Qt Quick. We'll learn about how to do user interfaces at a very basic level, so how to use what is there, all the components and concepts, and plug them into something that actually looks shiny and is nice and animated, because that's what it's all about, right? And then we'll talk about user interaction, so how to deal with mouse and keyboard events and other things. Second part, which is after lunch, we'll be getting into the wonderful world of states and conditions and transitions and state machines and things like that. This is the point where, if you're not a programmer, it says somewhere on the slides you don't need to know any programming, but it sure helps if you know computer science, because a state machine is a state machine. So we'll be talking about animations, about curves, about how to make things look natural. We'll talk about presenting data. This is obviously another big thing. You usually have something to display in your application, and you need to have a way to get what you already have in terms of data and present it to the user in new and interesting ways. Oops. Oh, I think I know what the problem is. There you go. Ha. There's a third part, which is about, let's say, the plumbing. How to actually make components for QML or for Qt Quick, how to make modules, how to make reusable things that other people can then build upon, or that you can yourself reuse in other projects. And then we get into the wonderful world of how to integrate this with existing C++ code. How many of you have existing C++ Qt applications that need to go to Qt Quick? That's about half, I'd say. How many of you want to start from scratch with Qt Quick? Just brand new application. Okay. Is there some existing template that you might want to look at, some existing application that is supposed to be redone? I would guess in the majority of cases that's the case. So you hardly ever start from scratch, right? Designers do. They make fancy mock-ups, and then there's nothing behind them, and then you're tasked with actually getting working code underneath this thing. So we'll spend some time looking at how do I get C++ code hooked up with QML and the other way around. How do I make C++ components available through QML? How do I get to the C++ from QML? So let's get started. First, we'll do an intro. I'll try to get to code as quickly as I possibly can, okay? First thing we have to learn, Qt Quick is kind of a beast of many names, right? Those of you who followed it for a bit longer have probably heard it called things like Qt Declarative, and right? Any other names you can remember? Yes, Kinetic is another one that was around. So these days, the whole group of technologies there is called Qt Quick, and at the heart of it is a language that we call QML. So QML, as we'll see in much more detail later on, is kind of the syntactic level of it, so that to clear up that confusion. QML is the language, Qt Quick is the whole suite of components and technologies. So we'll talk about things like elements and identities and properties and how to bind them. This is kind of the low-level QML layer. We'll make you familiar with the common elements that you have there. We'll talk about anchors in case you've heard that one before. Have you played with it at all again? Who's heard of anchors before? Okay, a few. And then the end goal of this first part is that you can take something that your designer has made and kind of transform it into working Qt Quick code. All right. So this is what it's made up. There is a declarative markup language called QML. Now, what's a declarative markup language? Well, hopefully, being programmers, most of you, you know what a markup language is, right? That's been around for a while, so you have your actual content and you mark it up so that it gets displayed in interesting ways. Now, what's a declarative markup language? Well, the term declarative programming has been around a while, and this concept of describing how things are instead of describing what they're doing, and then having the engine or the machinery take care of figuring out how to actually make it do that, that's a concept that's gaining a lot of traction in other areas, mostly the web. But it's now come to kind of rich client programming with QML, because you now do it on top of Qt. There is also a language runtime, because this QML is interpreted, right? It's, you can think of it as a JavaScript interpreter with some added bits on top of it. So it's a language runtime that executes your QML. Of course, there is an IDE, there's Qt Creator. Who works with Qt Creator here? Just, all right. Emacs? Ha, VI? Yes. Okay. As you can tell, I am a VI person. I actually fell in love with Creator, though. I've been quoted publicly saying that I don't think Creator was a very good idea because it was forking the community, and I thought they would have better invested time and money into making, say, Eclipse better. But I have since had to eat my words. I am actually a big fan of Creator now. It's a really, really nice IDE, and I think for Qt development, it's absolutely awesome, especially when you put QML into the picture, because it's one nice integrated thing that does everything, and it does it the same way on all the platforms. So yeah, Qt Creator. There's a graphical design tool which we will not cover today. That's mostly for time reasons. You could spend a whole day on that one. The other main reason why we're not covering it is because it just about became ready just now with the 4.7 release. So it's not at the point where we had time enough to actually build meaningful material to present to you. So that's at the go home and play with it stage at this point. And then the final missing bit, there is an actual C++ API which allows you to use this machinery, the JavaScript plus interpreter and the language inside your C++ Qt application. So that's what we call Qt Quick. Why? That's the big one. Well, the idea is that you've built applications with widgets, right? Most of you? With the classic Qt widgets. So you run into some limitations when you do that. As soon as you try and make things animate, as soon as you try and go away from rectangular grid-like layouts, as soon as you want to be a bit more flexible and a bit more fluid, you run into issues with the way that the widget system works. You also have the problem that it takes a lot of code to actually write something like make this thing go from here to here, right? If you've ever worked with animations in Qt, recently we've had some nice additions to it with the animation framework, but in the old days it was really quite a lot of code to get something to fly around the screen. And increasingly, people, for whatever reason, want things to fly around on screen. Now, if you're a VI person like me, you're thinking, what the hell is the benefit of that? But I'd like to quote a friend of mine, Aaron Saigo, who says that there is this thing with the tiger. And the thing with the tiger is that, we are evolutionarily at a stage where we are still kind of trained to run away from tigers, more or less, right? And tigers don't just pop up, right? We're really trained to notice things coming in, to have the tiger kind of appear on our radar, and then we start running away, right? So nature just doesn't work like Qt widgets, right? Whoo, there's the window. That's just not fundamentally the way we are wired, so we don't perceive that as very natural and very, very pleasing. So we can do better than that. We can try and be more natural in our interface design. We can try and integrate, animations and fluidity and intuitive behavior into our applications, and we need better tools for that, and that's where this comes in. Another reason for Qt Quick is that the idea is that you can make things a lot faster, right? Because we're way beyond the point where you design your application, you spend 5 years in specification, and you spend 15 years in implementation, and then it stays like that for 20 years. That's just not the way the world works today. You turn around applications very, very quickly, especially in the mobile space. Very often you have like 2-3 months to actually complete something, and then you have to redo it again 6 months down the line because the corporate design changed or user interface paradigms changed a bit. So the world is getting a lot faster, and we need something that allows us to build shiny things a lot quicker than before. That's the thing with a lot of code that you had to write with widgets. Hopefully with this, it gets a lot easier. Then there's the packaging problem. The thing that the web has over rich clients is generally deployment. If you build a web application, it's just there. There's nothing you have to do as a client. You just go to the web page, you use it, and you're done. Now, with rich clients, it's a bit more complicated than that. You have to install, download installers, run them, get the thing to actually work on your machine. You have all the different platforms and all that. So it would be good if we had something that was a bit more, fetch as you go and then execute type thing. A bit closer to the web paradigms of deployment. Yeah, I mentioned this as the tiger thing, in the real world, things are hopefully smooth. They're not actually. If you looked at the very first slide, it says that this would be presented by me and Stephen Kelly. Stephen is actually at the doctor's right now because he wasn't feeling very well. The reason why I would really like to have him here, maybe he can actually join us after lunch, is because he spent basically all this year implementing a rather large project based on this technology and has suffered through all the early adopter pains of working with pre-release and alpha and then beta software. So he's been more deeply in the trenches than I have, so hopefully I can get his expertise in later today. Another difference between Quick and the way we've traditionally done applications is the way the design is approached. Being VI people, well, I'll just lump you all in the VI camp here. As programmers, we tend to design interfaces that aren't necessarily brilliant, right? Let's admit it, that's not what we're good at. And while we have people, well, if we're in reasonable sized organizations, at least we have people that are good at it, it actually makes it pretty hard to work with them. Who actively dislikes working with designers and having prototypes thrown over the fence and then being told, you'll do it this way because that's the right way. Most programmers don't really deal with that very well. The other way around is true as well. Most designers are not very good at talking to programmers because we're difficult people, right? They're difficult people, we're difficult people. It's actually not a very smooth process generally. So what's missing in between there is some kind of a common language where the designers can express what they want and the programmers actually understand what that means and transform it into something that is a working application. And one of the beauties of this, and this is the bit that I'm personally totally in love with, is you can take a designer, you can teach them the basics of the syntax and the basic concepts, have them sitting next to you, and as you make up your machinery that actually has the application logic, they can start playing with the interface and they can continuously improve it, they can add animations, and they can express themselves with you. So you actually have a language where you can now communicate about what the application is supposed to be like. And that just makes for way better applications. It's a people thing, it's not really a technology thing. And this, by the way, it sounds like marketing, but it's actually true. I've seen this happen with a number of design people. Initially, they look at this and they say, this is programming, this is not what I do, right? Because they see JavaScript-y things, and then they say, well, it kind of looks like web stuff that I've done before, so maybe it's not that bad. And then they start looking at it, and they really understand the concepts quickly because it's expressed in terms that they understand. and then they very quickly start digging in and start helping you out with the UI. So this is really working well. I've mentioned JavaScript a few times. That's the language base that QML, the language, is based on. If you have never worked with JavaScript at all, I mean, nearly everyone has done some web programming at some point. JavaScript is kind of, it's a bit like C, but not really. So, you know, if you're a programmer, most people dismiss JavaScript as this script kiddie thing that other people do. But you do, it helps if you have a good understanding of JavaScript, and if you want to deepen that understanding, I suggest this resource. It's actually a pretty good guide. It helps if you've seen HTML and CSS before. Who has not seen HTML and CSS? There you go. Because it uses a lot of, Qt Quick uses a lot of rich text, and you can basically manipulate text this way, so it helps to know that. And as it says here, and I actually disagree with this bit, as you can tell, I don't work for Nokia, so I'm free to say this. I think it does require not programming, but it requires an understanding of computer science concepts. It really helps if you know what's going on underneath. So if you're a programmer coming to this, you have a much easier time. You can download the QML files over the network and execute them right away because there's no compilation step. It's an interpreted language, and that really gives you that kind of web deploy effect. All right, so we're this far away from code. Just bear with me. Getting back to the idea of declarative programming. Declarative, those of you who've done Latin know this, is, you know, you describe what something is. So you try and express as concisely as you possibly can your concept of what the application is. So if you were to approach, let's say you're given some prototype that animates something in, you look at it and you understand it in terms of, okay, there's a bit here, there's a bit here, there's a bit inside this other bit, right? And then this guy goes from here to here. That's what you understand when you look at it. Now, wouldn't it be great if you could just say that and it would work? Good? Good. Well, that's almost the way it is. You really start thinking about, I describe what I mean, rather than I say, okay, now I make a for loop which, you know, fiddles with some parameter that makes this guy go from here to here, because what you really want to say is, go from here to here, and do it nicely. So at the heart of this, there's a tree, if you will, to put it technically. And the elements have properties. That's the very basic model. We'll look at an example. So let's say you have this guy in your left, I guess. Yes. What is this? Well, it's a black rectangle, right? It's got a little rocket thing on it and some text. Text says Qt Quick. Rocket points this way. That's what you immediately see. So what you describe is a rectangle with a text in it and an image. And then you have this, the text is underneath the rocket, right? Translated into conceptual space, that's a tree of elements with properties. They have properties like an x-coordinate and a y-coordinate, a font or a size or a color. In code, this looks like this. So we made it to the code. I haven't checked the time, but I hope it was under 10 minutes. This is QML code, or QML markup, if you prefer. I call it code. It's code, right? Who thinks this is code? Smells like a duck, walks like a duck. Right, so at the top you have an import definition. To those of you from a C++ background, that's pretty much like an include. You fetch some stuff that you want to be working with. Since we're all within Qt, nearly all of the time you will import Qt itself, because that's the basic elements that you want from Qt to start working with them. And then in this case, we declare something called a rectangle. What do you think that is? It's easy, right? It's a rectangle. It's 400 by 400, and it's light blue. Okay, so this is, by the way, creator. This is the same example, so let's run it. Blue rectangle, 400 by 400. Easy, right? Now, imagine doing that with QPainter. Just, I mean, it's not a challenge to any of you, I'm sure, but just imagine the amount of code you would have to write to get a light steel blue rectangle to appear on screen with widgets. How many lines of code, roughly? 50-ish? Maybe? So hopefully you agree that this is actually a lot more lightweight if you're doing things like putting up blue rectangles. Obviously, if you're munging a database, this will not help one bit. But for blue rectangles, it's really fast. I'm sorry. your sarcasm detector needs to be tuned if you're working with me. So, I mentioned the import feature. There is something called modules. Modules group elements that you want to use, and you can import them. They're also versioned, which is very handy because you can provide new versions and you can limit the exact version that you want. This is another side effect of dealing with something that has quick turnaround times. Stuff breaks, right? You make a new version, you add something, it doesn't quite work like the old version. So I really want to be able to say, I want 4.7. I do not want 4.7.1. I want exactly 4.7, because that gives me precisely the feature set that I want. And if I install a new version, it has to provide the old version, and it has to work exactly the same way. That's really nice because it allows people to innovate, but still maintain somewhat stable APIs. So the API is versioned. Very nice. I wish that was the case for C++, but generally it isn't. So the guarantee, ideally, is that that particular version will not change even through future versions. Obviously, in practice, it doesn't always work that way. Actually, Qt 4.7.1 changes the syntax to be import Qt quick. Theory and practice, right? So this is already changing in the next minor version, but hey. Now what we're going to do in this example is define a light blue square. So you see that bit underneath there. So because we're good programmers, we describe what we want to do in a comment. Well, hopefully, ideally, this would be easy enough to understand that you don't need to put a comment on it, which is good, again, because it makes the code self-explanatory. But for the sake of argument, let's say we want to put a comment there. You have seen these comment characters before, being C++ programmers. It's the same as in C++. And this is our rectangle. A rectangle is what you call an element. An element is a thing. It's the unit in QML, right? So an element is just one of those bits that has a name and then has a body with curly braces. You always want to have the curly braces, trust me. Qt comes with a set of default elements that you can use, but of course you can also make your own. That's what you will do most of the time. And then inside the element you have something called properties. This is just, well, it's very close to the properties that we have in other areas in Qt. In fact, implementationally, those are QMeta properties, for those of you who have looked into the deeper areas of Qt itself. So this is Qt properties exposed with a nice JavaScript syntax. You can have them each on a line by themselves, or you can concatenate them with the semicolon. The semicolon, of course, being very familiar to you all. And you can also have it at the end of the line if you, like me, reflexively add semicolons to the end of everything you type. You can do that and it will not break. Syntax is name of the property, colon, and then the value of the property. What's missing here, if you're C++ people? Types. Someone said types. Well, it's the blessing and the curse of working without types, or largely without types. Things are easier to type, but they might be more difficult to understand, and you sometimes get surprises because the thing that you thought was an A is actually a B. So, C++ people tend to be really kind of type affine. They like types. Types are good. We want strong types, right? But this kind of goes out the window with QML. You have a lot less. You have strong typing, but you have a lot less control over types, and that's a problem. Getting back to the example, what we've just said is we want a rectangle, 400 wide, 400 high, and the color is supposed to be light blue. Now, what's the type of that color thing, for example? Ooh, do we want to know? Not really, right? The designer will just write this and just go, well, I said it's light blue, so it's light blue. Well, of course, underneath there's a lot of type conversion going on. This is actually a string that is then being passed, and it's a standard name, so the Q color underneath can actually find it and instantiate the right thing. So there's a lot of rigging there. But the QML syntax, that's why I'm pointing this out, kind of isolates you from all of that implementational detail. You just say the color is supposed to be light blue. What I ran here, when I ran this, is an application called the QML Viewer, which is just a little wrapper application that loads the QML widget and then displays whatever file is given to it. So this is what you work with the majority of the time. It's nicely integrated into Creator. If you hit, well, Apple R in my case, I don't know what it is in your case, then this thing will come up and show you your current QML file, which is really convenient. That's what you use for development. Okay, so getting a bit more deeply into elements. Elements are visible, but don't necessarily have to be visible. There is a base element, well, type. It's not a class as such, but it's a type, and that's called item. item is kind of the root of the hierarchy of elements that you then extend. You can think of it as the equivalent to QWidget, right? It's the base of the hierarchy. Now, just like with QWidgets, you often use them just for grouping, just as a top-level thing that contains other things. Because if you're working with the regular QWidget systems, you know that there is a tree of layouting going on there as well, and an object ownership tree as well. So item groups whatever is inside of it, and the other elements then extend that. Obviously, it doesn't have any appearance by itself, so you will usually want things that have an appearance inside of it, such as rectangles or text inputs. Of course, elements can also be things like states and transitions, because they're also specified in the QML syntax, so they need to be named with curly braces and a body, so they're also elements, but we'll look at those later. They have properties already, or you can extend them with your own properties. We'll also look at this. By the way, it's pointing to the QML elements documentation. I will not refer to that too much, but if you guys have laptops, most of you do, I do encourage you to break them out and open up the QML documentation in Assistant. I also encourage you to kind of hack along the examples, because to me, this is the kind of thing that really benefits from trying out. And as I show you the examples, you might want to go, okay, what happens if I make this red, right? So, because this is really important for actually getting a grasp of things, trying it out yourself, typing it out yourself, I do encourage you to do that. With this format, we can't really do exercises in the classical sense, where you start doing something and then I go check if you've done it right. That wouldn't work in this setting, so instead, I will show you mostly the solutions, and go through the solutions, but I do encourage you to kind of play around with them, change things, try out what happens if I move this over here, so that you get a bit of a feel of how it is to work with that. I won't be offended if you have your laptops open. You can even go to Facebook if you want to. Did I say that? So the elements, those are the bits with the name and the curly braces with the body, are usually defined by properties. Properties have default values generally. They have a type, so this is actually type, but it's not always obvious what the type is. And as we've seen, you can either use line breaks or semicolons. Why would you need properties? Well, you need to give things a name, so that you can refer to them in other places. And of course, you also want to change parameters of the elements. There are different kinds of properties. There are what we call standard properties. Those are the ones that we've already seen in the rectangle example. So if you have a text element, it will have a text property, which has a value. That's the text that you want to be displayed as part of the text. And it has things like the height. Nearly all elements have this kind of height and width thing, because it's about laying out things graphically generally. Then there are group properties. Those are really, you can think of them as namespaces, right? It's a group that is encapsulated with some prefix so that you can access them, as a separate entity. And it kind of namespaces the names being used there for the properties so that they don't clash with whatever you have. In this case, there is a font group property that has things like the font family, the pixel size. It's kind of, but not completely, like having a QFont object in C++ and then having setters on that QFont object and then setting it back onto the painter or whatever you're using with. Very, very important property, which is why we pointed out separately here, is the identity property. This is how you reference things. Nearly most elements that you need to reference will need to have an ID property. And this is important because here you're not dealing with pointers or objects of things, you deal with names of things. You address things by their ID. Now, to programmers, this might seem odd, because it might seem brittle. Who thinks this is brittle, referencing things by string? I mean, aren't we beyond that, right? But yeah, there's at least a few. That was my initial reaction as well. I mean, just identify something with a string, are you kidding me? But yeah, it's actually a lot more convenient than handing around pointers, and it's also a lot safer because this will not crash, generally speaking. Attached properties, this is interesting. Sometimes you have a property that might or might not be there, but could be useful. Something like adding keyboard navigation to an element. So the way this is solved in QML is you have what's called an attached property. So the key navigation is such a property, and it has a property called tab, which you can use to define what happens when the tab key is pressed. So this kind of, it's like a mix-in a way, right? You take something that isn't necessarily there and you add it to your element, and then you can use it. You can add your own, and this is the declaring part of declarative. if you will. So you can declare properties and extend your elements with them. So if you have a rectangle and you want that rectangle to have additionally something called mass, which you can then set from the outside, you would declare a property like this. It's a property, it's a real, so it does have a type, and it's called mass and has initially a value of 100. Or for a circle, you might add a radius, very useful to have for a circle, I guess. Now the fun part begins. Property binding. This is the magic machinery. In case you've been wondering how that actually all works, you know, you declare this nice tree of elements, and then you say go from here to here, but where's the actual code, right? Something needs to execute this transition, or needs to, you know, change the X in some way. So obviously there has to be some mechanism for making things react to other things. Now in Qt, how do you make things react to other things? Signals and slots, right? So you can kind of glimpse, maybe, possibly, how this might work under the hood. You have something that is, in this case, it's an item, so it's just a top-level thing. It has a size. Then there's a rectangle, which has a certain size. And in this case, we're specifying the width as 2 times the height, which means we are now referring to another property. That's called property binding. You're binding that one property to the other one. We'll see that you can get a lot more fancy than this, but this is the basic concept. You have a property and it references something else. Now, how does that work? If you think about it, what needs to happen for this to function? Remember, this is underneath, you know, still our old trusty Qt. It needs to take this and transfer it into something that does that just magically. Well, under the hood, there's basically properties. They have slots, if you will, that tell the system that they changed, and then there are connections made to the bound properties, and they will update whenever the original property changed. So it's still kind of underneath the hood the same things that we're used to, just that you don't have to write connect value change from this guy to set value this guy, right? So what you save is having to type all of that stuff. Instead, you specify, I want the width to be twice the height. Done. Kind of cool, right? Because that's really boring and thus error-prone code to write. And you've probably written tens of thousands of lines of code like that, and you probably don't ever want to write them again. So now, ideally, you wouldn't have to. So important to point out that these expressions are evaluated when needed, which means whenever you need to access, or well, the graphic system needs to access the width, it will compute the width based on the property bindings that exist. Let's look at the where is it? There you go. Can you see that? It's big enough. Let's see if I can. Ooh, wrong direction. Ooh, Creator has these extremely cool shortcuts for zooming. It's just hard to do on a trackpad. Okay. So it's our good friend, the light blue rectangle. You will see a lot of this light blue rectangle through the day. And in this case, we've added something to it. So we declare that there should be a text input inside the blue rectangle. We declare that it should be at x and y coordinates of 20. Relative to what? Yep, the parent, right? We're in Qt, it's actually really quite the same as in graphics view or in widgets. Positioning is relative to the parent. Now the parent, I call it the parent, but it's actually, it's also called the parent in QML, but it's the element that this element is within, right? One up the hierarchy. So what we're saying here is we want this to be 20 pixels off the rectangle's upper left corner. Basic concept is the same as in widgets or in graphics view. We want it to be 160 wide. We want it to have a pixel size of 32. That's a group property thing with the font. We want the text to be Qt quick. We want it to have focus, which is handy if you want to actually input something into it. And then we want to do, when the text changes, make it green. So it's saying there, on text changed, make the color green. Can you imagine what kind of code goes on behind the scenes there? Since you're all Qt programmers, or most of you. Well, there's a property, right? It has a signal that says my value changed, and there is a slot that actually sets the color to be green. You don't have to emit the signal, you don't have to write the slot, you don't have to do the connect, you just write. When the text changes, make the color green. That really does save a lot of time. Now, where does this magical signal come from? Well, as we'll see, you can declare your own signals. This is way into the day, but you'll learn how to do that yourself, and obviously the components that come with QML or with Qt Quick already provide the most handy signals that you would need. From a text input, obviously one of the ones you will need is that it tells you when it's text changed. So there is already a signal, and this kind of slot on text changed references that text changed signal, just like you would if you were to manually write it in C++. Okay, let's run it. There you go. So this is the point where the exploratory nature of the programmer would lead you to go, does it actually do this? Yeah, and the text change is cool. I can type something in here. And then I would start playing with, okay, so what happens if I take out this line? Oops. Oh, now I have to click it, right? So obviously there's a lot of magic already going on there, and initially when you start working with this, at least that's what I've seen most people do, is you play around a lot, right? You figure out how things behave when you leave out certain bits, because sometimes you'll see this throughout the day. If you look at the solutions to the examples, you go, why is that needed? And then after playing around with it for a while, you realize, oh, okay, it is needed because, and that's where you actually understand how this works together. So I do encourage you to, start playing around with it. It really helps. Okay. As I've mentioned, there is a very, very important special property, and it's called the ID property, or the identity property. They've chosen to use ID as the name of the property because you will type that a lot, and 2 letters are better than 5 letters. Or whatever identity is. It's not 5, is it? So most properties that you need to reference, or all of them need to have an ID. This is used for things like positioning. So you're saying, I want this to be next to this other thing, or I want it to be off by this from this other thing. But it's also used to reference properties of the thing. So if you want to say, okay, I want the width of this text input to be this, the text input needs to have a name, otherwise you can't reference it. You need this for animations, for example, where you change something like the x-coordinate of something, or the opacity, or whatever. Also, once you have something that has an ID, you can reuse it elsewhere as a component. So IDs are about relationships between objects. This is also what's being used, obviously, to do the hookup, the signal slot hookup that happens under the hood. Getting a bit more exciting here. Is that it's nice and sharp. So we're importing Qt again in version 4.7. Then we make a top-level item. We give it a width and a height so that we actually see something. What happens, by the way, if you don't do that? Well, nothing, right? Won't see anything. So it's kind of important to have this top-level item with a basic first idea of the size, because otherwise you'll look at nothing, no matter what you have inside there. Then we add a text. We give it an ID. We call it the text element. Not very original, but hey. We say that we would want it to be at X50 and Y25. We want the text to be Qt Quick. We want the font family to be Helvetica and the pixel size to be 50. Is clear? Okay. And additionally, inside this item, we want a rectangle. We want it to be at 50, and we want it at 75 Y. We want it to be 5 pixels high. We want the width to be the same as the one of the text element. And then we want the color to be green. So if you think again into how this would actually be done in regular Qt or in widget-based Qt, you might get an idea of the code you would have to write to express this. You could, obviously, you could do all of this with widgets, but you would write quite a bit of code. Now, in order to reference the width of this other element, we need to give it an ID. So you see the ID is text element, and then we reference the ID down there at the width property. So to express it in more technical terms, we are binding the width property of the rectangle to the width property of the text element that we have given a name. That binding obviously is a signal slot connection under the hood. What happens when you use text input? Well, that's the editable variant of text. Text is just read-only. That causes a bit of confusion because people tend to want to edit when they use a text, but that's actually a different one. It's called text input. Now, you might be thinking, well, that's all good and well for having light blue, steel blue rectangles with little images in them, but there must be more than this, right? I can't express my whole application in width and height. It does a lot more than that. So yes, there is, of course, also the concept of methods. Some things are just, well, a bit of code that needs to execute that doesn't have any visual representation or is not bound to any property. So timers are a classic example. I mean, how you need to work with timers somehow, mostly implicitly through animations, but sometimes you do want to wait for a certain amount of time, so you have to have a way to say that. And you can. There are methods on these elements, and they are exposed through the Qt's regular introspection mechanism, so you can mark things up to be available in this way, as we'll see later. The world is a bit simpler than elsewhere in QML. Everything is public. Yeah. Does that strike anyone as kind of dangerous? Yeah. You have things that are, I would call this the Qt namespace. It's actually not a namespace, but that's the way, as a C++ programmer, I tend to think of this. So there's a group of methods that is available on the Qt element, and these are things like time formatting functions and just handy utility functions that you need. You call them just like you would call any other JavaScript method. As we've seen, there are types. There are basic types for properties. You have numbers, you have your integers and your reals. You have booleans, obviously. You have strings, you have constants, so enums and flags and things like that. And you have lists. Lists are expressed with the angle brackets. And if you have a list of just one element, you can leave off the angle brackets, which is just handy syntactically. Looks a bit weird, at least to me, this list syntax, but hey. Then there's a fancy thing. Who's got a background in functional programming, maybe? Ooh, old people, where are you? So that's the thing with functional programming. Most people have heard of it and were supposed to have understood it at some point in their life, but never really quite got comfortable with it. Is that kind of, yes? Because I see some half-raised hands there. Well, the one thing that functional programming has going for it is what they call closures. You can have bits of code that are attached directly to something else, and they are executed basically in line as you go. Now, scripts, as they're called here, are such closures. They're basically bits of code that will execute and then have an effect on a property. So instead of having some method that operates on the property, you just write the body of that method straight behind the colon of the property, which is really neat. So that's a type. And then we have other types like the usual stuff that you want and that you have in Qt, like colors and times and dates and rectangles and points. Rectangles are awesomely important in QML. It's all about rectangles. No, I'm kidding. You also have some more advanced stuff like 3D vectors and things that you need for more complicated graphics work. Again, it keeps referencing the QML documentation. We don't really have time to look at all of this, so I encourage you to have a pass through that documentation. The thing with QML, it's reasonably recent, or Qt Quick is reasonably recent, so the documentation had to catch up with the rest of Qt. Who here thinks that the Qt documentation is generally awesome? I definitely do. The Qt Quick documentation is not quite as brilliant yet, let's put it that way. It's getting better really fast, but if you started working with it 6 months ago, you were banging your head against the whole thing all the time because there was very little documentation. So you had to refer to the code a lot, but they're really, really catching up, so it's getting a lot better quickly. So in case you have looked at it 3 or 6 months ago and were thinking, look at it again, it's actually getting much better now. All right, so as a summary of the basic concepts, in QML you define user interfaces using elements, name, curly braces with a block, and properties. Those are the properties of that element. So you have elements that are structures in your QML code, and you have items. Those are the visible bits. This is a bit like the difference between QObject and QWidget, right? So items are the visible ones. Mostly elements have properties that have a default value that you can then change. If you want it to be accessible from the outside, you have to give it an ID so you can reference it. And you reference other people's properties with something called binding. That's basically hooking up one property to someone else's other property. And then you have methods, which you can call on elements. And we've seen that there is a range of built-in types that you can use. So that's kind of the very, very basics of the QML syntax. Again, with this format, we have limited ways of doing exercises. What I initially had planned, had Steve been here, I would have had Steve do the exercise and basically converse with him to kind of show you how he goes through the motions of figuring out what that actually means. Unfortunately, since he's not here, we can not do this, at least not this morning. So I'll kind of have to recap. I encourage you to, when you review this material, which you very likely will, spend a bit more time on that and actually try thinking yourself, how that all goes together. There's a kind of a trick question here. What's the difference between a rectangle and width? Well, one is blue, clearly, and the other one is this kind of weird color, which I find quite unfortunate, to be frank. But so the rectangle is what they call an element, right? In fact, it's an item, because it has some visible bits to it, and the other one is a property. Creator shows them in these colors, that's how you recognize them. But obviously, also syntactically, they're very different. How do you create an element with an identity? Well, you give it an ID property, and you assign some value to that ID property. And then you use that ID property to reference the item elsewhere. Okay. Any questions up to this point? We do have microphones. If you have a question, I would ask you to raise your hand and shoot. Is there a microphone here? Sorry about that. It's being recorded, so it's important that people understand out there.
Since the items have IDs, which are strings, there is the danger that two different items will have the same name or the same ID. So
yes.
How ID conflicts are being resolved?
Well, it's nested. So the ID is nested within the element that you have. So yeah, obviously, if you have at the same level of the hierarchy things that are named the same, you will get a warning in the best case. In the worst case, it will just use the wrong one. But yeah, there is a certain danger of name clashes, which is why it makes a lot of sense to limit what you expose to the outside to those very few things that are actually relevant. It's the same with having all public methods. Obviously, if everything is public, you can clash with other stuff. But it's nested, so it's only relevant at the same level of the hierarchy. We'll look at grouping a bit more later, and then you'll see that you can actually do something like define an API for your module, where only at the top level you have some few elements that are actually exposed to the outside world, as in the same level of the hierarchy. Okay. Any other questions? Yes, can you? Just a second with the microphone here. Oh, there's another one. I've got two. I can make you guys jump.
Can I refer to the root elements without ID? To the root element properties without ID?
It's very hard to understand because of the echo.
No.
I'm sorry, can you?
How can I refer to the roots properties element from without ID?
You cannot. You can reference parent, so you can go implicitly up one in the hierarchy. You can also do stuff like parent, 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 but that's not very practical. So generally, you give everything an ID that you need to reference in some way. Okay. But yeah, you have parent as an implicit.
Thank you.
Yeah. Any other questions? Over there, sorry. Okay, yeah, shoot.
What is the difference between a string that is between quotes? Like, for example, you had the text property and you had a string to it and it was between quotes, and then you had the ID property, which was also a string, but it didn't have quotes. So is there some
quotes,
kind of,
you mean?
Yeah.
Like well, generally, strings are quoted. So I'm not sure if where you saw a string that wasn't quoted, but it should be quoted.
When you put an ID you had ID label or something and it wasn't quoted. So I was wondering if there's the difference between them or something.
Implementationally, there is, yes. Yeah. It's for all practical purposes, syntactically, it's a string. Implementationally, it's not. So, a bit confusing, yes. But strings are generally quoted. Anyone else? There was over there somewhere. No? Okay, let me check the time real quick.
There's one question here.
Yes, shoot.
What happens if you have a circular dependency between two properties?
You are in the wonderful land of undefined behavior. Well, that is a danger, sure. If two things reference each other and they have a circular dependency, there will be trouble. Generally speaking, it will warn you if you do that. You'll get warning output saying there is a circular reference between those two properties. So at property binding time, which is when the hookup happens, it will notice this because it has the objects, it sees the connect, so it can notice this. it has actually gotten a lot harder these days to produce these without getting a warning, but it's still occasionally possible, especially when you have more complicated cross-references across various files. So yeah, we'll see some techniques for avoiding this a bit down the line, but yeah, that's in danger. Any of these automatic hookup systems have the danger of producing loops, but it's pretty good at detecting them.
Okay.
Okay. Chani. Hi, Chani.
Hi. How do you make the parent item magically have the right size for its children? Do you have to use layouts for that?
Nope, there is something wonderful called anchors, which we'll get to in a minute. Layouting doesn't, well, there are things that work like layouts, but generally you position things relative to other things, and we'll see how that works exactly in a few minutes. Okay. So I'll show you in a minute. That's it for the moment? Okay. How does it look to you so far? Interesting? Exciting? Yes? Woo-hoo. You want to go home and rush to your desk and start hacking with it? Well, it gets a bit more exciting. So as Chani pointed out, there are, by the way, some friends in the audience from faraway places. There's a few Brazilians. There's at least one person from India. So I might occasionally reference some of you by your ID property because I do happen to know a few people in the audience. Sorry about that. That doesn't mean that I don't love the others just as much. So how do you actually lay out things? How do you make things position themselves? How do you give hints to the system as to how to move things about when they start moving? Well, usually you nest and then you reference your parent because that's your frame of reference usually for the layouting system. So in this section we'll look at how to do that. We'll talk about how to do collections of elements, so how do you make bigger groupings of things. We start looking at colors and gradients and images, which is the whole point of it. You know, it's supposed to be shiny. We look a bit more about text, and most importantly, we look at anchors and alignment. This is alignment is a term that you probably know from Qt, from widget layouting. There's a very similar concept here. So this is about spatial relationships between elements in 2 and sometimes 3D space. So nested elements. We start at the top again. Our friend, the light blue rectangle, makes another appearance. But this time, because we have grown somewhat tired of the light blue, we want something inside that looks a bit more interesting. Let's say a green rectangle, which is slightly smaller than the light blue one. So in this case, for sake of clarity, we're actually not saying it's a bit smaller than the other one. We're saying it's explicitly 300 by 300. And it's green. And then inside that green one, we again position another rectangle, this time white. We give it a specific size, width, and position. Hopefully, at this point, this should seem fairly obvious to you. Tree of elements nested within each other. There was a question earlier about referencing. Do you think it's possible to reference the green rectangle from the outside? So if you were to take this and put it into another QML file, can you reference the green bit? Who thinks you can? Okay, then I have succeeded because you cannot. You have to expose this to its parent and then you have to reference it via the parent. So you have to bubble it up and then you can reference it. But generally speaking, nesting hides. That's what I mentioned earlier. There is a certain amount of protection from clashes because things are nested, generally speaking. Colors. I already mentioned that they are magical. Well, they're actually not very magical. They're just QColor. So QColor already has all of these powerful conversion facilities for getting various representations of colors into the internal representation. So you can reference them by well-known names. Those are the names used in the SVG standard. SVG, you're familiar with SVG, roughly at least? Mm-hmm. Scalable vector graphics, neat way of describing images with XML. And they have a standard for names, and there's beautiful things in there, such as light blue and steel blue, but also, of course, the basic ones, red, green, etc. You can also use the RGB color space and just specify hex values for your RGB, or you can even call QColor methods, such as saying, I want red, green, blue, and alpha channel to be exactly this, and you have this method that you can call that gives you this. This, of course, maps directly to QColor, if you're familiar with QColor. Yes, we have alpha transparency. There's something called opacity, which is quite but not totally the same as the alpha channel that you know from from elsewhere in Qt. Some examples here. Red rectangle, green rectangle, blue rectangle, different ways of getting similar results. Hopefully, syntactically speaking, at this point, this should not be having any surprises for you. Is anything still unclear to anyone on this slide? Just reading temperature here? Okay, still with me. All right, let's look at images. Images are very, very important because QML or Qt Quick is being used on small form factor things. It's, of course, also being used for big desktop applications, but its kind of primary objective is to work with smaller form factors. And those tend to be constrained, resource constrained. You have not very much CPU, you don't have much memory, so you have to be clever about what you actually do in the interface. And images tend to be reasonably efficient for many things. So they're, for example, more efficient than gradients. So you end up working with images a lot. And it's good to know how to do that. You can reference them using URLs. Generally, people use relative URLs relative to the location of the QML file on the file system. That's just intuitive. That's what you would expect. There are some surprises when you start copying around your QML files and you forget to copy around the images. Then they will not display, obviously. If you're on an embedded device where you know your paths, you might choose to reference install locations that are fixed. Depends on your development style, whether that is more convenient or not. Obviously, you can do all of the interesting manipulations on images just like you can with Qt widgets, like scaling rotation around an axis or around a central point. We'll see an example in a minute. And there's our friend the rocket again. The rocket is, as you might expect, a PNG image. It's in an images directory, which, because we're neat freaks, we've put at the top level, so we have to go up one in the hierarchy, down to the images directory, and then reference our rocket. Syntactically speaking, this is a rectangle. It's 400 by 400. It's black, and it contains an image which is at 150, 150, and it displays this image. The nice thing about QML, you can almost literally read this just like I just did and immediately understand what it does. That's really nice because it gives you an intuitive grasp of what the interface will look like, well, ideally. Okay, you see the layout, the file system layout there. This is actually a good practice. Have your images somewhere, have your QML files somewhere else, and then make sure you have pretty clean directories with only certain things in them. It makes it much easier to build installers and things like that. Now, inside the image, we now see a magical property called scale. This obviously means how big the image is supposed to be. In this case, we want it to be twice as big as it originally is in the PNG file. There are, of course, limits to the scaling that you can do quality-wise. But assuming you have high enough resolution in the original image, you can scale it up or down and still look decent. Scaling happens, generally, the center of the thing is the reference point. So yeah, if you scale, it will keep the center of the image where it is. That might or might not be what you want. It's just important to know that that's what it does. Now, if we want to rotate this guy, again, rectangle contains an image, this one, and now we rotate it 45 degrees. Rotation is, as you might expect, clockwise, and it is, again, generally around the center. That's hopefully intuitively what you would expect. Personally, I've never gotten used to rotation clockwise. It always seems unintuitive to me, but that just might be my weird brain. Who thinks that this is not, I mean, I would not intuitively expect this to be rotated that way, but I don't know. You would? Is that a question? Or do you no? Okay. Come on. Yeah, if you want to change the point around which the rotation happens, or rather around which the transformation happens, there is a special property called the transform origin, which is the reference point for the transformation. So for scaling, it's the bit that stays at the same point, and for rotation, it's the bit that is rotated around. And what we see here is a reference to something that we'll see a bit later on. It's an anchor point. So in this case, we're saying we're referencing the top of the item, hopefully intuitively enough. So in this case, we're referencing the item, which is an image's own top. And now it rotates around the top. Gradients. Who's worked with Qt gradients? Widget gradients? Okay. If you've seen the API of that, which is essentially you define a range, and then you define points on that range between 0 and 1 where certain colors are to be placed. So if you want to go from, let's say, blue to red, you would say, okay, by 0.5 I have to be at this color, and then by 1 I have to be at this other color, and then Qt figures out the bits in between. Same is at play here. So you define what is called stop points or gradient stops, which say that a certain color has to be reached by this point in the range, and then the range is defined between 0 and 1. So normally you will have a start point and an end point, and then some points in between. The thing with gradients, they are reasonably expensive, at least on most hardware. There's some hardware that does them really well. That hardware tends to not do much other things really well, so it's not very popular. For popular hardware, generally it's more efficient to use images than gradients. Efficiency is important because if you're on a battery-driven system, CPU use tends to translate directly to battery use, and that's not a good thing. If you're carrying around a current smartphone, you might or might not get more than a day of use out of it. I never do. So this is currently the biggest or the scarcest resource in embedded devices is generally battery, at least portable embedded devices. So you want to be easy on the CPU, you want to avoid re-rendering the same thing over and over again. So if you have a gradient and it's a fixed size, by and large you will make it an image and just use the image instead of the gradient. But for rapid prototyping it's good to just be able to say, okay, I want a gradient from here to here, done, right? This is how you do it. We have a gradient nested inside a rectangle. The item is called gradient, intuitively enough, and it contains gradient stops. One at the start, which is green. It's actually not very green here. And one called blue at the end of it. Now there's a quirk here. And that's the orientation, right? Because how do you define that? What do you think? Do you think there's a property where you set orientation, maybe? That's what I would expect. You rotate it. Well, maybe that will change. I hope it will change. But for now, you declare it this way, and then you rotate it whichever way you need it. So, yeah, in this case, that's what people usually do. They pre-render the gradients into an image file, and then they display the image file. That's good practice. Okay, going into text. Oh my God, it's a light blue rectangle. It has read-only text on it. The text reads Qt quick. It's displayed in Helvetica at 32 point, or actually 32 pixel, sorry. You can also specify point sizes. So what we're not saying here is how wide and how high this thing is, right? So the width and height are actually automatically calculated by the font metric system, which you might or might not know from widgets. There's QFontMetric, which is a nice handy class that allows you to say, given this text, how wide will it be? And under the hood, this is exactly what's going on. Because you can use rich text there, you can use HTML. This is already quite powerful. You can do fancy things there, and you don't have to worry about making sure that it's the right size, and it'll just automatically, more or less, do that. Editable in text instead of text, you just use a text input and you're done, in theory. Then you get into the wonderful world of handling text input and focus and all of these things. But in theory, if you want it editable, you use a text input instead of a text. Okay, differences to widgets. What's different with this guy from a QLine edit, which you probably all have used before? Well, a few of them are on there. It has no decoration, right? Usually line edit will have this white background thing, and you'll have some kind of a frame around it, or you might even have grayed out text for completions and things like that. You might have all kinds of keyboard shortcuts to manipulate the text in there. You have selection behavior, you have navigation behavior, go back to the first character, go to the last character, all of that. Now, this is not a line edit, right? This is text that you can edit. Now, the problem with this, I think, at this point, is that people have come to expect features from things like text input, notably completion, notably being able to just do, whatever selection, Control A or whatever, and that should just work. Now, most of these things by this point actually do work in this text input, but they have to be kind of added on again. So in some weird way, it's a re-implementation of QLineEdit, which is 12 years old and has 12 years of experience in it, which does seem odd to me in some respects. There is, however, hope. There is a project in the works called Qt Components, which is about re-merging, reuniting all of the logic and all of the know-how about how to do interactive widgets that is in the widget stuff with this new way of rendering them, which that's essentially all it is. Because ideally, you would want all of the features that you have in QLineEdit available in this text input thing as well. At least optionally, you can still turn them off. But it would be nice for, usability reasons if you could easily attach a screen reader to this and it would just work the way you're used to, right? So I think this is not the end point of this, at least not in terms of implementation. In terms of API, it's just fine. It's just that implementationally, it's somewhat lagging behind what we're used to from widgets. Now, the people who work on this quite rightfully say that, well, you're doing completely different things with this, right? You're not supposed to have completers in there, and But we've worked, for example, on an email client for the N900, and it does have email addresses that need to be entered, and they do need completion. And you don't want to type all the long domain names in there. Why would you? I mean, this is a feature that's been around for 10 years, so people do expect this. So what do we end up doing? Well, we take a QLineEdit, we plug it into this QML thing because we need all of the features. Now, QLineEdit might be not a very convincing case here, but quite a few times we've run into this where we had to take a widget and plug it into the QML thing simply because the widget had all of the feature set that we needed, and the QML kind of still is reasonably primitive with respect to the feature set that it exports. So there are some limits to this. Okay, so right before lunch, I think I have about, 20 minutes, perfect. We do need to talk about how you actually do layouting. Now, in Qt, one of the, I've done quite a few Qt trainings over the last few years, and when we get to the section about how to do layout, especially for people coming from other widget sets, they generally look at Qt's layouting and go, damn, that's nice, right? Because it's really quite easy and intuitive. So in some ways, I'm sad to see that kind of go. In other ways, of course, it's also very limiting. It's pretty hard, and this is another thing we see in the trainings a lot. It's very hard to get, non-standard layouts out of the Qt layouting system. Anyone tried that? It's like getting fancy stuff out of it. Who's failed? Okay. If you use animations, if you want things to fade, if you want things to partially cover other things, it gets really complicated with widgets. So I do appreciate the fact that this is more flexible, but it's not quite as easy to get the result you want, not for the simple cases at least. So there's a bit of overhead, I'd say, for simple cases. So how do you do this? You specify the position and the alignment of things relative to what's called anchors. Anchors are points within other elements and other items because they need to be visible. And those are generally things like the left or right side, the horizontal center, the vertical center, the top, the bottom. But there's also things like the baseline for text, right? So you can reference certain well-known points within elements and then position yourself relative to them. Now, you can also use this for expanding into things. That was the question that Chanya had earlier. How do you say, I want this to be as big as the other one? You would do this by filling into your parent. Let's see a code example of that in a minute. So our good friend, the light blue rectangle, has grown up now and has an ID because it needs to be referenced by other things. We call it rectangle 1. Why not? We add a text, this is read-only text, remember, to the rectangle, and we say that there is it's supposed to say center text, it's supposed to be green, it's supposed to be Helvetica at 32 pixel, and we want it to be centered within the parent. Now, the way this is expressed here is by saying we want to center in relative to the anchors. Well, we look at the anchors of the parent, and we want to center in the rectangle 1. So we reference another element, and we say that our center in anchor is supposed to be that. Syntactically, this is where it stops being really nice to read, right? I mean, if you know what it does, you read it as I am centering within the parent. But it's not quite as, it doesn't roll off the tongue as the other QML stuff so far has, right? So this is where it gets slightly quirky syntactically, I find. So in this case, we are not centering relative to an anchor. That semantically wouldn't make much sense. We're filling out another element, or centering in another element. Now, if we take away the ID property again of our friend the light blue rectangle, as I mentioned earlier, there would be still a way to reference that because it happens to be our parent, and the parent is kind of a well-known ID that we can use to reference the thing that we are nested within. So we would be able to say we want the text to be centered relative to the parent without having an ID property on it. Let's try a bit of a different thing here. The light blue rectangle has gotten smaller. It loses its ID, it gets smaller. It's not looking good for light blue rectangle. We have a text inside of it. It's called right align text, fittingly enough. And in this case, we are saying, I want my right anchor to be anchored to the parent's right. Right? I'm throwing an anchor out the right side of the boat and tying it to the right side of the parent. Does that make sense to you? Yes? Now, the more adventurous of you are now thinking, what if I do this, and then I do anchors left, parent left? Right? What if I overspecify the anchors? If I start causing conflicts? That is, in fact, the problem. Because generally, you have to be a bit gentle with this. You have to give it hints, just enough hints to get the layout right. But if you start trying to nail it down too much, you take all of the power away from the layout and dynamics that happen behind the scenes. Because if you now start to expand the parent, if you've specified too many constraints, you won't get the results that you need. That is, in fact, exactly the same thing that happens with Qt layouting. If you start nailing down fixed sizes and alignments and paddings and things like that, you don't get what you want either. So it's the art of finding out what to be as tight as you possibly can in specifying what you want to achieve, and then finding exactly that one statement that gives you that. There is a lot of trial and error involved with getting to that point, at least in my experience so far. This being young technology, I'm sure that some best practices will emerge over time as to how you do certain things and how patterns are done, but at this point, it's mostly trial and error. So, just to clear up a point of confusion there, you do parent.write, which gives you access to the right side of the parent. You don't do parent.anchors.write, right? I might have given you a hint earlier as to why that's not the way you do it. Those are at the top level exposed as explicit things that you can reference. Margins. This is about getting some extra space in between stuff, because you generally don't want things sticking directly to the anchor points. You usually want them to be a bit off. So you can use margins to specify some extra space between or relative to anchors, just like you can with the layouting system in Qt, in QWidgets. So to give you a somewhat real-world example, let's say we have a light blue rectangle, and then we have an image and a text, and we want them to be next to each other. We also want the text to have certain, to behave in a certain way relative to the image. So what we're doing there is we're saying there is an image that we call book. We reference a certain source file for it, an SVG file. We want it to be basically anchored to the left of the parent's left, or our left should be the parent's left. We want there to be a bit of space, and we want that to be relative to the width. So we're saying, please make 1/16 of the overall width available as a margin on the left. And then vertically, we want to be centered relative to the parent. We have another bit of text. We call it, the text is supposed to read writing. Don't give it an ID in this case because we're not referencing it. Set the pixel size. And then we say, okay, we want this guy to be tied to the left, to the right, sorry. So we want our left to be tied to the book's right. This is where the syntax gets. And then we want there to be a bit of space, 32 pixels. Okay. And this is another one of those anchors that wasn't in the first slide about anchors. It's called the baseline. And this is very handy for text because the baseline, for those of you who've worked with text before, you probably have heard this before. The baseline is the thing that the letters sit on. So the lowest point of the G is below the baseline. Generally, you want text to be laid out relative to the baseline, not relative to the actual bottom or the actual top of it, because letters go above and below that. Okay. So this is how you specify what you want. In this case, we've hooked one to the left and we've hooked one to the right of that. So you've specified the writing relative to the book and then the book relative to the parent. Okay? I think that's the, yes. How can you, which anchors can you use? Well, you can specify things relative to your parent, to your children, or to your siblings. Siblings are, logically enough, things that are at the same level of the hierarchy as your own element that you're within. So, and that's the only thing that makes sense, right? You're either specifying your direct parent, which you have some frame of reference to, or things that are at the same level as you, or things that are within you. This creates dependencies on the geometry. As someone pointed out earlier, it's probably pretty easy to get yourself into a loop there if you specify down and up the hierarchy. So generally, it's a good idea to reference as locally as you can, by which I mean you have one thing referencing the parent, and then you have the other things referencing siblings, just like we did in the examples earlier, rather than everything referencing up or things referencing down. So a quirk, if you want to call it that, is that you can only use a margin if you've actually used the corresponding anchor. So if you're not specifying that your left needs to be relative to something, setting a left margin will have no effect. This might be confusing, especially in the previous example. You might be wanting to say, I want the writing to be off from the right-hand side by at least this. Yes? If you set this without setting the right anchor, nothing will happen. So you can only specify margins for anchors that you're actually using. I've said constraints a few times. I hope you guys, being largely programmers, that's a term you've heard before. Constraints is the way declarative systems works. You basically say, I have some rules. I'm setting down some rules as to how the layouting is supposed to do, and then this constraint solver goes around and tries to figure out how to actually make that possible while still maintaining all of the constraints. Now, those constraints should be minimal, as I said, so you generally want to have some things that are reasonably fixed. Obviously, the easiest one is the top-level one, but it really helps if you have some well-fixed place-positioned elements and then you start referencing relative to them. That makes life so much easier. So some well-known, stable, static things that you can then hook the rest to. If you don't have a default size, you should anchor it to something. Why? Well, it's pretty hard to figure out how big it's supposed to go, right? If it's just not really anywhere. So the layout algorithm obviously has limitations. It needs to have reference points. Without reference points, it can't figure out how big things are, where they are. So you do need to give it enough hints to get it right. Okay. Now, let me see. I think I mentioned fixed items. Yes, make sure you have IDs, right, on any kind of big, well-known items that you have, because that allows others to reference them. It says items that dominate the user interface. Yeah, I mean, I appreciate the attempt to write down some best practice here, but to be quite honest, I don't think we've collectively yet understood how to do this really well, because even with over a year of experience with this, you still find yourself getting really confusing stuff to happen and not getting the results that you want, because I think there is just not enough best practice yet in the industry to really know how to do this well. So we're still exploring there, but a few things we do know. Big guys that you need to be there all the time, they really help. Okay, bit of an exercise, since we are actually approaching the lunch break. I would leave you with this exercise. I think there's a second one, yes, there's two. So this first one, you're supposed to produce these three rectangles nested within each other. You are then encouraged to experiment with things like, what happens if I specify negative coordinates? I mean, you can guess it, or you can just fiddle around and see what happens. You can try and figure out, does it actually work to put something totally off screen? You know, what happens when I reference anchors that aren't actually visible, or move my thing outside of the visible space? So you can play around a bit with that. And or, if this is more your thing, you could try and reproduce the gradient-based thing here, if you're more about just playing with the visual side of things and maybe playing around a bit with gradients. The idea of these exercises is just to get you writing some QML on a syntactic level. I would encourage you to look at the handout, which you should all have received. There's a little USB stick, hopefully, in your possession at this point. Nope? There is? Yes? Who has one? Awesome. You can keep them. On this handout, you will find exercises and labs and solutions. So you have starting points. You can open those up in Qt Creator or in VI. I encourage you to use Qt Creator. It does really help. And then start playing around with them, adding things to them, hitting the shortcut for run, and just see it pop up and play with it. Since there is no compilation step, it's really quite nice and quick to just change things and see what happens. Okay, there's another exercise here. For those of you more inclined to playing with the property stuff in more detail, you can also, of course, do this. So what I would suggest, there's a big lab which we'll look at after lunch, that I leave you with this. You have some time to play with it. Lunch is supposed to be at 12. I think we are 5 to 12 now, so you have a few minutes to play around if you want to, and then we are supposed to reconvene. Does anyone have the thingy? Is it 12:30? It's 1, right? 1? Okay, so we're supposed to start again at 1. I do try to start on time, so you would do me a favor if you're here a few minutes early, because with a lot of you, it takes a while for you all to settle down. So please be here at 1 and play around with the exercise. There are a few people in the room who might be willing and able to help you if you have some questions. Otherwise, approach me. I'll see you later.